So we're still solving equations today, except today our variable is going to be on both sides of the equation. So when it's on both sides, I can choose which side I want to leave the variable on. And then I'm going to make sure all of my variables move to that one side. And then I'm going to make it so my other side is a constant side. So all my numbers go to the other side. Once I've moved everything over, I solve it like normal by combining like terms. And solving for my variable. So taking a look at this first equation, what's the first thing you want me to do? This looks like a huge mess right now. Okay, so I can put the 3x and 4x together by combining like terms. So what's 3x plus 4x? Okay, and then the 10 stays the same. What do you guys want me to do on the other side of the equation? You know you have this on your paper. You don't have to look at the whiteboard. No, I'm just looking at this side right now. No. So think back to our warm-up today. What were we doing on the warm-up? Distributing. So I want to go ahead and distribute the -2. Okay, so -2 times x gets me -2 times x. Okay, -2 times -4. I always keep the sign with the number on the outside and then multiply. No, I'm multiplying. Positive 8. Plus 9.
You can simplify to -2x plus 17.
Okay, exactly. So I can combine like terms again. So which side do you want me to move all my variables to? Do you want me to move them to the left side? Left side? So I'm just going to make myself a note. This is going to be the variable side. And this is going to be my constant side. Remember, constant means numbers. So what do I need to do to move to the variable side? What needs to move? The 7x or the -2x? How do I move that? I want to add 2x to both sides. So 7x plus 2x is, and I still have that 10, 17. And then, what should I move over to move to the constant? Okay, so I'm going to subtract 10 on both sides. What am I dividing by 9? Both sides? Okay. What do you mean? Like, we gotta... It's their notes, yeah. Yeah, because I can't simplify 7's prime. What does prime mean? No.
Number is a number that can only be multiplied by itself as one.
Mm-hmm. Okay. So questions on that first equation that I solved. No questions? Okay, I'll give you more time to write. Okay, so on my next equation, what is different about this equation? What's different? Okay, I don't have to combine like terms at the beginning. But when I go to distribute, what's different about that number on the outside? It's a fraction. So what I'm going to actually do is I don't like working with fractions, so I could distribute. But I'm going to choose to hold off. What I can do instead is I can move that 7 over and then multiply to get rid of that fraction. I could write less and then it wouldn't be very helpful notes. So what I'm going to do is I want to get rid of that 7 first. You're right. I'm just going to wait for people to finish copying this down. Okay, so I want to start off by adding 7 to both sides. So the 7's on my left side will cancel out. Negative 2n plus 6 plus the 7, what is that going to change into? So the 6 plus 7 gets me, if you can't do this in your head, remember you can use a calculator. 6 plus 7? 13. Okay, so instead of distributing that 1/2, I am going to get rid of it. What is the opposite of multiplying by 1/2? Okay, I could divide by 1/2, or I can also, remember, fractions are really division, so this is really telling me divide by 2. What's the opposite of dividing by 2? Multiplying by 2. So I can multiply both sides by 2. On my left side, the 2's will cancel out. It's a positive 2 times a negative 2. So it's going to give me negative 4n. And then I'm going to do the 2 times the 13. Okay, what do you guys want me to do next? No. The regular 4? Without the variable? Oh, the 4n? Okay, so I'm going to add 4n to both sides. Because the opposite of a negative is positive. Yes. Remember, this end has a secret 1 out front, so 1 plus 4 is 5n.
5n 4 equals 26. 5n 30.
When would we do, Molly? Okay. Yep. What is 26 plus 4? Where? Okay, so questions on solving this. You just add one more step at the beginning, you move it over to the other side. Okay, so on the back side, I want to solve this again. Just like we've been doing before. So what is my first step here? Yeah, so my left side's going to stay the same. I still have 4x plus 6. And then on the right side, what's 2 times 2x?
4.
4x. 2 times 3? 6. So I'm going to go ahead and keep solving. So what do you want me to do first? Which side do you want me to make my variable side? Left. So I need to move this, 4x. I'm going to subtract 4x on both sides. Why not? Because it's a positive 4. So Molly just said it gets rid of both. That leaves me with 6 equals 6. No, but is 6 equals 6? Is that a true statement? Yes. Yeah. So if these two numbers equal, it is always a true statement. It is always a true statement. Okay, so what my answer here would be is infinitely many solutions. Those 3 words. Because no matter what I plug in for x, it's always going to equal the same thing. Okay. So this equation is true for all values of x. Quiet down. For all values of the variable, the solution is always going to be infinitely many. Okay? An equation that is true for all values of the variable is called an identity equation. Stephen, watch your language. Watch your language. Okay, so what do we want to do next in B? Okay, so left side stays the same. I'm going to have 6x minus 5. And then if I distribute, what's 2 times? Okay. Okay. What do you want me to do next? Close. Subtract, because the 6x is positive. So then I get negative 5 equals 8. That's not true. Yeah. Do you understand it now? Okay, so since there are no values of x that make this equation true, the equation has no solution. Questions on the difference between infinitely many and no solutions?